Plans for Planner. Introduction. This article reviews the attributes of low pace noise (SOS) and some recent techniques applied for pace noise reduction in micro trip planner technology. Focusing on plan. The modern regime of wireless and other communication systems depends on the spectral purity of signal source such as oscillators and spectrally pure microwave oscillators and echoes keep bit error rates low, which ensures multi-level modulations and high performance of wireless communication system. Eco attributes for pace noise reduction. In the development of vehicles with microstrip planar technology, most oscillators are constructed using an inductors capacitors tank circuit topology with negative resistance and feedback resonance because LC resonators are suitable for operation in the frequency range due to low self resonance. Guess the stress. Unlike the time domain representation of jitter oscillators, the frequency domain is applied for phase noise analysis to near carrier phenomena under ideal conditions. A typical LC tank circuit oscillator restore amplitude variation by stabilizing the limit cycle, but the pace variation remains uncontrolled and escalation due to the infinitesimal change of biasing in the active device. Vico design using model. Generally, a poor loaded Q of the resonator and BPF significant oscillatory system figure 2 system with a spectrum based gain where is the frequency of interest. According to the Backhouse, the relationship between the input and output ports at carrier frequency found as X. Noise power spectral density and offset frequency from the carrier as the frequency dependent amplitude transfer function and as the frequency dependent phase transfer function. This model is valid for ring oscillators differential oscillators and LC tank circuit oscillators. Compensation for amplitude variation is found in LC tank circuit oscillators, thus the amplitude transfer function approaches zero. Usually LC tank circuit oscillators and VCOs use series and parallel feedback topologies. Near carrier phenomena due to up conversion. The near carrier phase noise is analyzed by applying an impulse injection of noise on the oscillators. Time varying signals its zero crossing and peak status. In the case of an LC tank circuit, showed that phase noise is at its highest when the impulse at the zero crossing and that amplitude deviation is maximum when the impulse is injected at the peak of the time varying oscillators. Signal this is noise is injected into the periodic output signal of an LC tank circuit oscillators. Q is the question. The successful design of a low phase noise VGO depends on the Q of the resonator. With high Q facilities, the reduction of phase noise in LC tank circuit because in microstrip planar technology, and so improvement draws in the most attention among phase noise reduction techniques for VCO. Design generally, the definition of Q is the ratio of stored energy to the energy in each cycle of resonance. The stored energy is the difference between the highest values of the resonator's magnetic and electric energy at the resonant frequency. The future at glance. In the case of resonator design, it is better to use complex Q-based techniques rather than employing the group delay peak-based techniques, as the latter do not directly slow the type of DC source needed for active components. For the Merck, there is an precise length of parallel feedback lines for works using group delay peak-based techniques. Conclusion. This article reviewed different techniques involving microstrip planar technology and phase noise reduction in oscillators and because the attributes of low phase noise were described to introduce design selectivity for applications. Recent techniques was particularly emphasized to introduce the suitability of recent techniques. Future research is expected to introduce other techniques phase noise reduction.